My name is Denis Niedenzu from the University of Cambridge, and I'm working with Mukesh, who gave the presentation this morning. By now, we've heard that there's quite a bit of waste we've been generating, so it might be food waste or many other types of waste. And I'm going to talk about plastic waste. The presentation is going to cover three main areas. I'm going to give a little bit of background information because we know it's a massive amount we generate in terms of waste, but what is the dimension? So what does it compare to? Then the second bit is a couple of components we need to be thinking of if we want to tackle plastic waste. And I'm going to give a couple of upcycling examples towards the end, since we're on at an upcycling conference. So it's quite a bad time to give a presentation because everyone will be sleepy, I suppose. So let's just add a couple more questions to the session. So how many people in this room eat plastic? No one. Yeah, it sounds quite silly, doesn't it? But let's phrase it a bit differently. Are there any seafood eaters in the room? People who eat seafood? My team, yes. Wonderful. We've got some seafood eaters here. And actually, all of you who eat seafood do eat plastic as well. So, in fact, we consume up to a plastic bottle of this size a year, just by eating seafood, and there are many other examples how we consume plastic. So it's not just an environmental or economic problem, but it's also a problem for us humans because there are many health consequences as well. So it's a multidimensional problem. So how big is it? We've got a couple of numbers here. So for example, this chart here introduces the plastic waste production, plastic waste generation, and the plastic waste treatment from 1950 to 2015. So if we look at the top part, we see that 8.3 billion tons of plastic has been produced until 2015, and nearly 80% of this plastic that has been or had been produced is waste. And of this waste, of these 6.3 billion tons, we have, again, roughly 80% that's landfilled or is polluting the environment. And in fact, landfill might be polluting the environment to a certain extent as well, so this classification might not even be entirely true. This source is one that's distinguishing. But if you think about landfill, what happens is we dump waste somewhere, but there are lots of animals that might go to the landfill and look for food, take some of the packaging or whatever it is, fly away, drop it somewhere. So it's actually a pollution as well. So landfill is kind of pollution to a certain extent. And what do these huge numbers actually mean? So imagine the size of South Korea, 100,210 square kilometers. If we think about this size and dump all the plastic waste we've got, we would have South Korea covered about 5 centimeters deep in rubbish. 5 centimeters over the entire side of South Korea. Let's think of it a bit differently. You've got a very nice little is the wrong word, it's a fairly big tower actually, Lotte Water Tower, which is 545 meters high. If you take the size of this Lotte Water Tower, the base size, and then dump all the plastic right next to it of a similar area, how tall would this tower stand? It's 16.4 kilometers, just a plastic tower basically. And this is 30 times the size of your very famous tower here. So it's a massive, massive problem. And I think the dimensions are quite staggering. So now, in order to tackle this plastic waste challenge, we need to understand a bit more what exactly is this plastic waste. So what is the segmentation? So what we see on the left-hand side is about 50%, a bit more than 50% of the plastic waste is due to plastic packaging. So when we go in stores and buy food, there will be a lot of plastic. We had previous examples, and this is actually more than 50%. Here on the pictures we've got pharmaceutical products, we've got bottles, and so on. The next field with 6%, so significantly less, is electronics and electrical goods. So smartphones contribute to 6% of the plastic waste being generated. We've got the building and construction industry, about which Kirsten talked this morning, and the plastic waste being generated is about 5% of the total plastic waste. And we've got various other segments which amount to 37%. So I'm going to show a couple of examples during my talk, and due to the sheer size, I'm going to focus the examples mainly on plastic packaging, but it doesn't mean that we should only be focusing on that bit. It's just an example. So when we talk about tackling the plastic waste challenge, we can also see from the historical data, or we had the historical data, and we can also see here what's being done yearly at the moment with plastic waste. So in 2016, in the UK, we had about 78 million tons of plastic packaging being generated. 40% were landfilled, 14% incinerated, only 2% recycled, and 32% polluting the environment. So this is just to give you a glimpse of what's happening annually. So this is valid every year, whereas the previous charts were historical charts. So now, what can we do about it? If we think about tackling plastic waste, we think often about recycling in most of the cases, and in some instances reuse, which Kirsten mentioned as well this morning. However, what's behind it is not just methods, technologies or material. We have a system behind tackling plastic waste, and that's a very important thing. So a system, if we define it linguistically, it's a set of things working together as parts of a mechanism or an interconnecting network, a complex whole. And this is very important to understand, and I'm going to tell you in a minute why. So if we tackle plastic waste, we're not just looking at technologies and we're not just looking at materials. For example, of the interdependencies of a system, we start with the material bit here, and if we decide to go for certain material in plastics recycling or plastic packaging in the first place, we consider ecology, we consider physical and chemical properties of the material, and we consider also the consumer behavior. So when we need to deal with plastic waste, as this shows, we cannot only focus on what happens after the waste is being generated, but also what happens before that. And this consumer behavior, for example, is a thing in the design process of the packaging. So companies would like to sell their products, so of course they have a certain type of packaging. At the same time, we need to ensure environmental feasibility. So that's also a decision in a complex system. So it's a very big mix of decisions before the product even goes on the market, and after that, in order to tackle the problem. So let's look at the architecture of a system. So if we decide, for example, we've got a certain type of packaging and we would like to recycle it, we need to understand whether we can do it. So here, this might not be a problem, but in other parts of the world, maybe if we look to rural areas in India, there might not be a recycling system in place. So again, when tackling plastic waste and deciding what the best method would be to deal with plastic packaging, we need to understand the geography of where the system is. And also, again, consumer behavior on this side is very important, because imagine we set up a recycling system and consumers don't do waste separation, or they don't provide us the material. We cannot do anything. So we heavily rely on consumer behavior in order to tackle plastic waste. And there is different types of systems with which we can tackle plastic waste, and many complex interrelationships in this system. Quite a nice example, which is, to my knowledge, also located somewhere here in the building, or next to it, is TerraCycle. And this company provides containers, for example, in which customers can place their rubbish. So you go online, you order these different containers, you collect your waste and send your waste to TerraCycle, and they take care of it. You don't need to do a lot more. You just have to get these boxes, collect your waste, and send it to them. They do the recycling bit for you, and that's done. So the conventional recycling system, if we talk about types of system to tackle plastic waste I mentioned previously, is for the recycling system, number 1, collection, number 2, sorting and grinding, number 3, washing of the plastic, and number 4, melting and casting the dry plastic flakes into pellets. What we've heard about recycling is one of the most important things is it's generally downcycled. So when we take plastic or plastics in general, and we recycle it, it doesn't have the same quality anymore. And that makes it quite difficult for businesses to do recycling, because obviously it needs to be economically feasible as well. And much of the money, or much of the investment is actually in the second bit, the sorting and grinding. Why? Because there's such a wide array of different plastics being used, it makes it quite difficult to recycle, because with plastics you cannot just dump many different types of plastics in a bin, shred it, grind it, and use it again. They all have very, very distinct chemical properties, and this makes it very challenging. So there are lots of different sorting technologies in place which are quite expensive. So the economies of scale of recycling is sometimes not great. And additionally, the properties of the material make it quite difficult as well to recycle cost efficiently. A second type of system is a reuse system. So a reuse system is a system that basically uses a product over and over and over again. So if we look at the production process and then the cycle of reuse, we got at the start, before the product is manufactured, the extraction of raw material. The raw material supplier will supply the raw material to a manufacturer. The product is being created. The product, when it's being when it has been manufactured, is going to be distributed and consumed. And afterwards, if we stick to the example of plastic packaging, the plastic packaging might be collected. Then we have a quality control, and if the quality of the product is of the packaging is fairly okay, we might recondition it, or we might remanufacture the plastic packaging, or we can go directly into use or reuse. So there are actually 3 types of circles. If the product or the packaging quality is really good and we can just reuse it, we do the reuse. If the quality is slightly worse but still in an alright condition, we can do reconditioning, remanufacturing. And this actually helps us create a lot of value and not lose the value due to recycling. So one very nice example is the company Replenish. It's a company that provides washing liquids, and what you can see on the left side is a container, and initially this container is filled with washing liquids. So when you've used all the washing liquids, you can order so-called refill pouches. So these refill pouches can be seen here, so they go here, and I'll show it on the other side as well. Refill pouches go here. It's a very, very small piece of equipment, and then you put water in the bottle, mix it with this concentrate, and you have dishwashing liquid again. So this shows us the amount of packaging being used for another washing liquid is significantly less than if we were to buy a completely new product. So that's quite an interesting company that does the reuse refill bit. When we come back to recycling, which we initially talked about, I mentioned there are lots of different technologies and sorting technologies, which is the main problem in recycling. And I brought you a little chart just to show you the variety. So if we take sorting, and classified into manual sorting, automatic, combined, we can then go down the automatic track and see when we do automatic sorting, we've got dry sorting, we've got wet sorting, we've got chemical sorting, and underneath there's so many different types of technologies. So for example, dry, we've got X-ray sorting, wet, we've got froth flotation, chemical, we've got hydrolysis. So there are many different types of technologies, all very distinct and special to certain types of plastics, and all very different in how much they cost. So this is just to give you an overview about the complexity of this process. So what generally happens after the sorting as well is not all materials can be grouped into something, which means we've got waste at the end. And there's quite an innovative solution to it. So after the sorting, if we still have waste, we can use a certain equipment in which we dump the plastic waste, and this machine converts the plastic waste into fuel. So it's kind of a circular approach to dealing with plastic waste. So if the sorting doesn't work, we can still do something with it. Here's another example how to enhance the recycling quality and make recycling more affordable and more accessible. This example is from Ronan, who can't be here unfortunately today. He's one of our lecturers in the Institute for Manufacturing, and what they are currently looking at is the mechanical properties of the plastics, because when we recycle, the reason the material is downgraded is that we have chemical bonds we destroy irreversibly. So that means the material input is the output of the process would never be the same quality as the input. So now Ronan is trying to understand the mechanical properties and chemical properties and how these properties can be maintained during recycling to make sure that the recycling process generates the same quality as the material that was put in. So here are a couple of examples of tasks or challenges from the material perspective for recycling. So all different types of plastics have various characteristics, and what's also a problem is many different types of plastics are very difficult to track. And if something is difficult to track, of course it's very difficult to sort as well. And that means again, if we can't sort for recycling, we have trouble with the quality. So all we can do is basically downcycle the material. So what would be quite interesting is to look at other technologies that can additionally facilitate recycling, sorting processes. And Ronan proposes, for example, digital printing, which can be used to label the different types of plastics. So we know exactly during sorting what this particular type of plastic is. So overall, it's all about enhancing the sorting quality and using other technologies that can facilitate it to make recycling a lot more affordable and improve it a lot more. So I promised also to talk about a couple of upcycling ideas, because after all we're at an upcycling conference. And what we see on the left is a company called Gumdrop, and it's a really interesting company. So what they do is they manufacture bins, the pink thing you can see there, and they put it out somewhere on the streets. It could be a very busy area in Seoul, for example. And this bin is there to collect chewing gums. So when you chew chewing gum, you can put your chewing gum in these bins, and once the bin is full, they collect the bin for you, or for the city, and recycle it. So they recycle the bin with the gums, with the chewing gums, and make new bins out of it. So that's a way to upcycle chewing gum, which we use. Another example for the more creative people amongst us would be to use it as flower pots. So we've got lots of very, very innovative examples of upcycling here in this building. This could be another one where we use plastic bottles and put nice flowers in it. Then on the left side we see intelligent design solutions where we can use plastic waste to create goods. And on the right hand side we have again a very, very interesting kind of technology. So this technology on the right hand side, these microfluidic arrays, can be used to actually clean water. So there are it's a product that is being manufactured out of plastic waste and dumped into basically a system in which the dirty water goes, and then it cleans it. So we have clean water again. So this is another very, very innovative way to use plastic waste and to upcycle it. So we talked about three things here. We talked about the background of plastic and the dimension. We've talked about the system perspective. We talked about upcycling solution. And this is the most important slide. I really want you to take this with you. So if we want to tackle the plastic waste challenge, we always have to do the system thinking. We cannot just say it's only a technology bit or it's only a material bit. There's so many different parameters that need to be taken into consideration to tackle the plastic waste challenge. So it's a link between system thinking, technology, and materials. And what I'm currently doing is I'm on the systems side of the process. So I'm currently developing a reuse system. I'm designing a manufacturing system for reuse of plastic packaging. And also I'm creating an evaluation model for this reuse system, because after all, we can only do it, this reuse if it's economically and environmentally viable. So I'm on the top part, technology, material for other people, and everything integrated and tailored to each other will help us tackle the plastic waste challenge. Thank you very much for your attention.